Good morning, guys. I'm going to answer the questions that you guys had asked yesterday that we didn't have time to finish, as well as a couple more questions that I got emailed between yesterday and today. So we're going to go ahead and jump in with those. All right, so the first one, and this is one that was emailed me yesterday, is from 6.4, number 71, and we are looking to match up this curve with the actual trig function, the sine or cosine function that this would match up with. So this is a tricky one because, as you can see, the center of this is kind of going through 1. And I know I said that the sine curve normally starts at 0, 0, and the cosine graph normally starts at its top or bottom. But this is actually a cosine curve because it's a cosine curve that's been shifted up 1 and then reflected upside down. So what we have here is actually y equals negative cosine of something plus 1. So again, the plus 1 has shifted the cosine graph upwards, and then the negative in front of the cosine is flipping it around, so that way it doesn't start up at its top, it actually starts at its bottom and then goes through its progression. Okay, so we can see that the amplitude here is still 1 because it's going 1 unit up and down from the center line. And the period, as you can see, is 3/2. After 3/2, it starts over. So what we're going to do is we're going to set the period 3/2 equal to 2 pi over omega and solve for omega. So if you multiply omega to the left and multiply 2/3 to the right, the reciprocal, that's what you get. So that's going to be your omega. So you get 4 pi over 3 x. Okay, so there you go. The other question, one of the other questions that was emailed to me was number 93, which says that several research papers use a sinusoidal graph to model blood pressure. Suppose an individual's blood pressure is modeled by the function that you see here, where the maximum value of P is the systolic pressure, which is the pressure when the heart contracts or beats. The minimum value is the diastolic pressure, and T is time in seconds. The heart rate is the number of beats per minute. What's the individual's systolic pressure? Okay, so it said that that was the maximum. So if you think about what this graph is going to do, is it's going to start up at 100 because it's a sine graph, and it's got that plus 100, so it's been shifted up 100 units. And then the amplitude is 20, so it's going to go up 20, down 20 from 100. So it's going to peak out at 120 and have a minimum of 80. Again, this is your vertical shift up 100. So that, that B value shifts the graph up by 100 units, and then your amplitude 20 is going to have the sine function bob between 20 up and 20 down from where it's starting at 0, 100. So again, the question said that the maximum value of P is the systolic pressure, and part A said, what is the individual's systolic pressure? So the answer to part A is going to be 120. B says, what's the individual's diastolic pressure, which said was the minimum value. So that's going to be 80. And part C says, what's the individual's heart rate? So the heart rate is going to be how many times it beats per minute. And it said that T was measured in seconds. Okay, so 1 beat is going to be 1 period. Okay, so we got to figure out what the period is and find out how many times that period happens over the span of 60 seconds. Okay, so let's see, period is 2 pi over omega, which is 7 pi over 3. So you can cancel those pi's out and take the reciprocal of 7/3 and get 6/7. So 6/7 of a second is the period. So the question is, how many times does 6/7 happen over 1 minute, which is 60 seconds? Need my calculator now. Hang on one second. Actually, if you're trying to figure out how many times it beats in a minute and it takes 6/7 of a second for it to beat, what you actually would want to do, sorry about this, would be to set up this little equation right here and say, if it takes 6/7 of a second to beat, how many times, how many x's, how many times does it go through a cycle over a span of 60 seconds? So in that case, multiply by the reciprocal of 7/6 to 60, and you get 70. So that's going to be 70 beats per minute. So that's number 93. Okay. Then you guys had a few questions on 6.6 on the phase shift stuff. So let's go over there. The first one we're talking about was 6.6, number 11, which was y equals 4 sine of pi x plus 2 minus 5. And the question's to find the amplitude, the period, the phase shift, and the graph the function. So remember, what I like to do is I like to start by setting the argument of the trig function equal to where I would normally like to start the graph. Now for sine, I like to start at 0. So if I solve that, this one's gonna be nasty. I'm gonna end up starting at -2/pi. So good question here. This one's pretty nasty, I can tell already. That also turns out to be your phase shift. Remember, your phase shift was phi over omega. So phi is going to be -2, and omega is pi. So -2 over omega is also your phase shift. So that's where you're starting. That's your phase shift. Your period is 2 pi over omega, 2 pi over pi. So 2. And you want to end your graph 2 later than where you started. So what's 2 plus -2/pi? I don't know. It's -2/pi plus 2. So that's where I'm going to go. So that's for my ending point. Okay, now I need a middle point, a quarter point, and a 3/4 point. So my middle point is going to be halfway between the start point and the end point, and that's going to be a little tricky. So remember, the way you do that is you add the 2 points and divide them by 2. All right, so if I add those 2 points together, I'm going to get -4/pi plus 2. And if I divide that by 2, I'm going to get -2/pi plus 1, which, now that I think of it, makes complete sense. All right, shouldn't half of the change between -2/pi and -2/pi plus 2 be -2/pi plus 1? And in that same line of thinking, would this next point be -2/pi plus 1/2? And the third point, or I guess the fourth point, be -2/pi plus 3/2. So really, each point is incrementing by 1/2 of an x value beyond the prior point. Okay. Now, if you stick this -2/pi into the x over here, the pi's will cancel out. You get -2 plus 2, which is 0. So you end up with 4 sine of 0 minus 5. And so that -2/pi plugged into the x is just going to cancel out the plus 2 over here. So then you'll just have left the 1/2 pi, so pi over 2. And we'll get, as this wears on, all the things that we're used to getting: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Just like we drew it up. Okay, consulting the unit circle that you now have in your brain. The sign of 0 is 0. 0 times 4 is 0. 0 minus 5 is negative 5. Sign of pi over 2 is 1. 1 times 4 is 4. 4 minus 5, negative 1. Sign of pi is 0, so negative 5 again. Sign of 3 pi over 2 is negative 1 times 4 is negative 4. Negative 4 minus 5 is negative 9. And then at 2 pi, you should be back to where you started at negative 5. So your graph would be pretty far down. 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are the points I want to label: negative 1, negative 5, and negative 9. My first point is at negative 2 over pi. So I want to put that somewhere on the x-axis, but I'm going to throw that on my calculator real quick just to give me an idea of where that is. That's at negative 0.6 something or other. So I'm just going to throw it right here and say that's negative 2 over pi. Then when you add 1/2 to that to get your next point, that's negative 0.14 about. So I'm going to throw that right there. This is not going to be pretty. So it's negative 2 over pi plus 1/2. Then if you go negative 2 over pi plus 1, that brings you to like 0.4. I'm going to put right there. Call that negative 2 over pi plus 1. The next point would be like 0.8-ish. So negative 2 over pi plus 3/2. And then the last one would be at like 1.4. I'm going to put right here. And call that negative 2 over pi plus 1. Like I said, I knew this one wasn't going to be pretty from the get-go. All right, so let's throw our graph on there. So at negative 2 over pi, our first point was negative 5. Then we went up to negative 1. Back down to negative 5. All the way down to negative 9. And then back to where we started of negative 5. And then you put your sine curve in between it. Something like that. A little more rounded. Okay, and just kind of keep your graph going in either direction. So let's make sure I answered the question. It was asked for the amplitude. I actually didn't give that, so let's go ahead and give that real quick. The amplitude is going to be 4, right, from the coefficient of the sine right here. The period, which, yep, we figured that out. That was 2. And the phase shift, which, yep, we figured that out and we graphed it. It didn't ask for domain and range, so we can just move on from here. All right, well, there you go. If you have any questions, feel free to pause this before, because I'm going to move on, but you can always pause the video if you need this to linger a little bit more for you. All right, next is 13, which is y equals 3 cosine of pi x minus 2. Plus 5. So once again, this is going to be nasty again. I can tell right away, because you're going to want to start this guy, same as the last one, by setting the argument equal to where you normally like to start your cosine graphs, which is 0. So unfortunately, when you add 2 divided by pi, once again, you're going to get 2 over pi. Well, this time 2 over pi, last time it was negative 2 over pi. That's going to be your phase shift. And that's going to be where you start. So again, we're going to get a bunch of nasty values once again. Your period is 2 pi over omega. So 2 pi over pi, which once again is 2. So we're going to end 2 units beyond where we started. And before I forget, the amplitude is 3, right? Okay, but now that we've done one, I think this is going to be a little bit more natural, right? Halfway between something and something plus 2 would be something plus 1. So if that's halfway, then half of that would be something plus a half. And then on the other end, something plus 3 halves. All right, so refer to the last problem for much of what's going to happen now. I'm going to get cosine of 0, cosine pi over 2, cosine pi, etc. This happens every single time if you've done it as meticulously as we're doing it. Cosine of 0 is 1, so 1 times 3 is 3, 3 plus 5 is 8. Cosine of pi over 2 is 0, so 0 plus 5 is 5. Cosine pi is -1, -3 plus 5 is 2. Then back to 5, then back to 8. Okay. 2, 3, 4, 5, 6, 7, 8. So your first point, 2 over pi. Your next one, 2 over pi plus a half. The next one, 2 over pi plus 1. The next one, 2 over pi plus 3 halves. The last one, 2 over pi plus 2. All right, so put your points on there. First point was 2 over pi up at 8. Remember, the cosine normally starts at its highest or lowest point. Next one, 5. The one after that, 2. Back to 5, back to 8. So your curve, something like that. And again, just keep it rolling in either direction from there. Again, I'm going to move on, but feel free to pause if you need to catch up on writing this. 17, y equals 2 tangent of 4x minus pi. You guys definitely asked all of the hardest questions, which is good. So here we're going to start by setting the argument equal to where we normally like to start. But remember, tangent is the weird graph. That graph you like to start at -pi over 2 because that's where its first asymptote is. Actually, this one's not that weird. If you add pi to the other side, you get pi over 2. And if you divide by 4, you get pi over 8. So that's not a horrible place to start. Okay. Now your phase shift, though, technically is not pi over 8. The phase shift is basically the value of x that would make your argument be 0. And for sine and cosine, we said equal to 0, so we get 2 for the price of 1, the start point and the phase shift. But for tangent and secant, which we like to start at -pi over 2, the phase shift would not be the same thing as where we're going to start. So the value that would make the x, or the value of x that would make the argument be 0 would be pi over 4. And that's pretty much useless information other than to answer the question that the book is asking. There's no amplitude here. You only get amplitudes on sines and cosine graphs, so you can skip that part of the question. The next part would be the period, which is pi over omega, not 2 pi over omega, right? Tangent and cotangent have a pi period, so pi over omega. So we're going to end our graph pi over 4 beyond pi over 8. So pi over 4 is the same thing as 2 pi over 8. If I add that on top of 1 pi over 8, I get 3 pi over 8. So halfway between those would be 2 pi over 8, also known as pi over 4. Halfway between 2 pi over 8 and 1 pi over 8. If you add them up, you get 3 pi over 8, and divide by 2, you get 3 pi over 16. And then on the 3/4 point, if you take 2 pi over 8 and 3 pi over 8, add them up, that's 5 pi over 8, divide by 2, 5 pi over 16. Add them up and divide by 2. All right, for a tangent graph, you would always get negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. And that is happening by plugging these x values back into the original function. And you can work this math out and verify that this is actually going to work, but that is what's going to happen. And you're going to start and end on the vertical asymptote. Because tangent is y over x, and x is 0 at negative pi over 2 and pi over 2. Tangent of 0 is 0. Tangent of pi over 4 is 1, so 1 times 2 is 2, and tangent of negative pi over 4 is negative 1, so negative 2. Pi over 8, 3 pi over 16, pi over 4, 5 pi over 16, 3 pi over 8. Stick those asymptotes on there. Let's label 2 and negative 2 as well. Get out here. 2, negative 2. There, there, there. Kind of ran out of space. Didn't give myself. I just opened up like 7 calculators accidentally. So there you go. It looks something like that. And then of course you have a bunch more of these as things go on. And I always like to kind of hit the y-axis appropriately. So it looks like probably be going over through 0, 0. Yeah, okay. All right, cool. So there's that. And then the last one, this was also one that was emailed to me, was to write an equation of a sine function that has the given characteristics. That has an amplitude of 3, a period of 3 pi, and a phase shift of negative 1/3. So we want to come up with a sine function that has those properties. All right, so if the amplitude's 3, you can go ahead and just throw a 3 right there. You could throw a negative 3 right there if you want to be fancy, because that still is an amplitude of 3 because it's an absolute value, so feel free. The period is 3 pi, so you're going to set 3 pi equal to 2 pi over omega. And as you solve for omega, you're going to get 2/3, so 2/3 x. And then remember your phase shift is going to be, well, I guess I could say it this way. It's the value that's going to make your argument be 0. All right, so your argument is omega x minus phi. We don't know what phi is. We know the phase shift's negative 1/3, so that means we know phi is going to actually be plus, right? But if we solve this, we'll just figure out what phi is. So, wait a second. Oh, right. But for x, I'm actually going to plug in, I'm sorry, guys, my bad. Let me back that up. I know that negative 1/3 is the value of x that's going to make my argument 0. All right, so by having a phase shift of negative 1/3, that means I know that if I plug in negative 1/3 for x, I'd be at 0 for the inside of the sine function. So doing the math there, I get 0 equals negative 2/9 minus phi. Adding phi to the other side, phi is going to be negative 2/9. Again, we assume that phi, or that the formula is omega x minus phi. So being that we got a negative 2/9, it actually makes this a positive 2/9 inside of the sine function. And you can double check yourself, right? If you set that equal to 0 and solve for x, you should get negative 1/3. And, you know, just for kicks, if I want to add 7 or something to this, I totally could, because it didn't say anything about it having or not having a vertical transformation. So that's just me being weird for no reason. Okay, cool. Well, hopefully that answers all your guys' questions. And if there's anything else I can do for you between now and tomorrow at 9:30, just let me know. I'm available all day today to help you. So if I don't hear from you, good luck, happy studying, and see you at 9:30 tomorrow for the test.